Hi guys, in this video we're going to spiral back to those growth and decay word problems, but this time around we are solving for a missing value. So I had already recommended to you the first time we saw these formulas that you either quickly memorize them or have them all written down on a sheet of paper so that you can reference them quickly. So the first one, a population grows continuously. First of all, I know that this is a key word. At 3%, I also know that percents need to be changed to a decimal. Find the number of years it will take for the population to double. So in situations where they don't give us the initial amount, but they tell us what is going to happen to the money, it doesn't matter what you put for your initial amount, as long as you double it. Or if the question said that you want the population to triple, you triple it. So I know from the word continuously, I'm going to be using this formula. And I know whatever I plug in for my initial value, my ending amount has to be double of that. So I would pick something easy. I mean, the easiest one to do, honestly, is 1 and 2, but I'll just put 10 and 20 so that we can see it a little bit more than just putting 1. Remember, E is not a variable. My rate is 0.03, and I am solving for time. One thing that also sometimes helps when you're doing these word problems, for some reason, when the variable is on the left, sometimes that just makes a difference in how your brain can process the steps and what it needs to do. So if you find it helpful, you can always put what it's supposed to equal on the right-hand side, and a lot of times that will help. So I'm going to need a log because my variable is the exponent, but remember the base and the exponent are the only things that can be on the side. So I'm going to have to get rid of the 10. So I'm going to divide. And see, this is why it doesn't matter what initial value you pick. The first step is going to be to divide. And so by this step, everybody is going to have 2 because they doubled their initial amount. All right, from here, now I can change it to a log. So when my base is E, I'm going to need ln. My argument will be what it equals, and that is 0.03 t. Now I'm not done with this side because I'm multiplying by t. I'm running out of room here, so I'm just going to copy it. So I'm going to need to divide. So this is what I will plug into my calculator. So ln 2 divided by 0.03, it's about 23.1 years. All right, next question. The value of a house has increased. What annual rate did the value of the house increase? So it doesn't say compounded, it doesn't say continuous. My amount is increasing. So it's just the regular growth formula. My initial amount is 90,000. I don't know the rate. I can figure out 2005 to 2020 is 15 years, and this should equal 140,000. So this is not exponential. So I will not be using a log to solve this equation because look at what my variable is. R is not an exponent. So this is going to be just a regular get R by itself type of situation. So the 90,000 is being multiplied. So anytime we're solving an equation, we want to work backwards from, please excuse my dear Aunt Sally. Yes, I'm adding something, but the thing that I'm adding is in parentheses, so that will be the last thing I can do. So then I have to look for multiplying and dividing. So I'm going to divide And I'm going to leave this as a fraction for now, only because I don't want to round too early in a problem. If you start rounding as you're working it out, your final answer is going to be less and less accurate. So I'm just going to leave that in fraction form. All right, now I'm just going to do a little reminder over here. If that equation had said x squared, you would square root it. If that equation had said x cubed, you would cube root it. So the fact that ours is something to the 15th power, we are going to need to take the 15th root of whatever that number is. So in the calculator, that would be math and option 5. In Desmos, you probably have to hit the keyboard and go over to functions, or you're going to look for some type of square root function that has like an n there that you can change. But another thing that you can do is take the reciprocal of the exponent. So I'm going to erase that, and they're the same thing, so it doesn't matter. I personally think the reciprocal exponent is easier to type into the calculator, but it's the same thing, so it doesn't matter. So x to the 15th power can get canceled out by doing 1 over 15. And then you'd have to do the same thing over here, because whatever you do to one side, you have to do to the other. So if you raise to the reciprocal of that exponent, that's another way that you can cancel it out. But either way, we either need to take the 15th root of 14 over 9, or we need to raise that to the 1 over 15 power. So I got 1 plus r equals, and I'm almost done, so at this point I can kind of just look at the decimal point. And it looks like that's going to round to 1.03. And then just look, we're not done solving for r. I have to subtract 1 on both sides. So my rate is 0.03. This problem is expecting you to put your rate as a percent. So to turn it back into a percent, we have to multiply by 100. So the rate is 3%. All right, next problem. The population of a town increases 12% every 5 years. So this doesn't say compounded. But it's also not happening every year. It's happening every 5 years. This piece of information is on your notes about compound interest. But basically, we need to spread that apart over the course of 5 years. So our exponent is actually going to be t divided by 5. Anytime you're going every 2 years, every 3 years, every 4 years, your years has to get divided by that number. So our initial population was 15,000. 12%, I'm going to make sure I divide that by 100. So that's 0.12. My number of years divided by 5 will give me the new population of 60,000. All right, so again, I need to divide this. I will need a log this time because my exponent is my variable. And I'm going to go ahead and simplify this because that's not going to be too bad. So I'm going to make that 1.12. That came out to be 4. So at this point, I can turn it to a log. So my base is 1.12. My argument will be 4, and that will equal t over 5. So again, I'm not done. Think about what will need to be my last step to getting t by itself if t is getting divided by 5. I will have to multiply by 5. So 5 times log of 1.2, argument of 4. And I got 61, about 61.2 years. All right, last problem that we're going to do together in this video. Our money is earning 2% compounded monthly. Find the number of years it will take for your investment to grow. So I know I'm using this formula. So my initial amount, 2%, remember to change that to a decimal, so that's 0.02. Monthly means 12 times a year. And my final amount. All right, so again, I'm gonna have to divide by 100. And I am gonna go ahead and clean this up. I'm gonna simplify that. But again, I'm gonna hit math enter enter because I don't wanna round that too much. So when I simplify that and change it back to a fraction, it's pretty gross, but the calculator is going to do the rest of the work anyway. But that's the fraction that I got. And that side is 1.5. All right, so I am going to need a log. I'm solving for the exponent. And my base, I don't care which one you use. Either you have to leave the base as what this was originally, or put our simplified fraction as the base. My argument is 1.5, and it equals my exponent. So after I figure out what this is, I will still need to finish getting t by itself. So I'll have to finish dividing by 12. So when I type that in the calculator and then divide that number by 12, I get about 20.3 years. All right, so use these examples to help you with the 6 or 7 examples that's on the scavenger hunt.